Hello, everyone. I'm Tok Luong, the CEO and co founder of Body Data. I was planning to give this presentation live on stage in Lugano, Switzerland, but unfortunately, at the last minute, my schedule did not permit it. So I'm doing this presentation virtually, but two of our engineering staff from Belgium, Yannick and Hamlet, are in Lugano attending the conference with you. So if you wish to speak further with Body Data after the presentation, please seek them out at the conference. I'll give a few seconds now and ask Yannick and Hamlet to stand up so the audience know where you're located. In this presentation, I'll be speaking about our Technology Innovation Award-winning Cora handheld 3D scanner. In late 2018, I was on stage in Lugano speaking about a prototype of our Cora scanner. A lot, of course, has occurred since then. We did release version 1 of the Cora in late 2019, but never had a chance to deploy it because of COVID. At the height of the pandemic, all through 2020 and 2021, we pretty much put our heads down at Body Data and work on version 2 of Cora, and additionally develop a full comprehensive end-to-end size matching solution we call Measure, Match, Manage. I'll touch briefly on that as well in this talk. We released our Measure, Match solution, Manage solution, in October of 2021 last year. Included in our offerings are 4 different ways to create a person's body dimension profile. The first is a self-measure method in which, with our guidance, an end-wearer can measure 5 dimensions of their body, and we can predict the rest that are needed in order to give them the recommended size. The second method is a 2 photos method, taking a front and a side photo of the end-wearer with any smartphone. This is the same 2 photo method that you will see in many of the products out in the marketplace that offer size matching. This 2 photo methods has a restriction. It requires the end wearer to wear tight and form-fitting clothing for it to have a chance to be accurate, because optical-based camera system cannot penetrate clothing. In addition, it's a 2-dimensional photo and lacks the 3rd dimension of being the depth, so it can be limited in trying to estimate the accuracy of a circumference of a 3-dimensional body. The 3rd method we offer is a 360 video with LiDAR using a high-end iPhone and iPad. The LiDAR is the depth sensor which gives us the 3rd dimension, and therefore we can create an accurate 3D cloud of the end wearer being scanned. The 4th method is really the most technically advanced method, and that is our Technology Innovation winning Cora 3D scanner, capable of scanning an individual fully clothed with no restriction and measure the body underneath the clothing. We have successfully deployed our Measure, Match, Manage solution, including version 2 of our Cora 3D handheld scanner. Let's talk about the Cora technology and what distinguishes it from others in the marketplace. As mentioned, it's the only 3D handheld scanner capable of scanning an individual fully clothed in any ordinary street clothing and measure the body underneath the clothing. And the Cora technology is only available from Body Data. It's IP protected with patents granted in all the major markets. Cora overcomes an obstacle that all optical-based solutions face. Optical-only based solutions require tight and form-fitting clothing to be accurate. We know this to be true because we offer 2 optical-based methods ourselves. Both the 2 photos and the video with LiDAR methods require tight and form-fitting clothing to be worn. We know optical-based technology well and are open to discussing the pros and cons of using it, since we offer all the methods. The photos you see here on the screen are from a deployment we did for a city municipal Transportation Division in Canada. We scanned the bus drivers after their shifts to put them into the appropriate work uniforms. As you can see, we can scan them in whatever clothing they happen to have on and measure their bodies underneath the clothing. Frictionless. Our Quora technology patent deals with fusing data from multiple sensor types to reconstruct an irregular object like a human body. I should point out that we also own the original patent associated with the two photos optical method. This is through our acquisition of Quantacorp, a Belgium company that owns the original patent associated with the two photos method. Let's talk about the Quora hardware. Our Quora 3D scanner uses both optical depth and millimeter wave radar sensors. Millimeter wave is the key ingredient here and is the same radar technology used in the TSA booths you see at the airports. The millimeter wave passes right through the clothing and bounces off the water molecules on the human body surface. Our usage of millimeter wave is low power and very safe. You see here the 3D optical cloud that we generate by scanning this woman wearing this dress. You also see the body, the 3D radar reconstruction of the body surface underneath the clothing. You can clearly see the gap between the outer clothing and the body underneath. I like to say that no optical-based scanning method can scan a woman wearing a dress and tell you accurately the dimension of her thigh. Where you can see clearly here, we can. Millimeter wave technology removes the barrier that optical technology faces. We have deployed and will continue to deploy our current Quora V2. When we first developed the Quora V2, we used what were available at the time. For the depth sensor camera system, we used Intel's RealSense, model D435i. And we used the Windows Surface Pro using USB 3.0 connection. Because at that time, the Windows Surface Pro was the only tablet with a fast USB 3.0 connection. USB-C and stuff was not available back then when we started. We will replace these three items with version 3.0 currently in development. Our experience on developing the 360 video with LiDAR scanning method led us to move off of the Intel RealSense depth camera. We saw that the optical cloud stitching is cleaner and less resource intensive using the Apple built-in LiDAR technology. This in turn means higher, longer battery life, and it means more scan per charge. In 3.0 version 3, data transfer will be done through Wi-Fi and avoid cabling altogether and the mechanical issue associated with that. This is because a lot of the radar processing work has been moved into the hardware, and thus less of the radar data. It's more post-processing that is transferred to the tablet, and then we fuse with the other data to reconstruct the human body underneath the clothing. Now let's talk about the Quora software, which is really the secret sauce and the base of our patent granted in all the major markets. As mentioned, it fuses data coming from multiple sensor type like the optical depth and the millimeter wave radar, along with other data sources to reconstruct an irregular object like a human body underneath the clothing worn. The fusion diagram you see here, I actually grabbed off of the internet because it was available, and it shows related to car self-driving system, fusing similar data sources together to determine the environment surrounding the car. In our case, similar thing is happening in terms of the fusion of the data sources, but we fuse the data to reconstruct the human body underneath the clothing. You can think of it in simple term of that we use the optical system to stitch the person being scanned together with the clothing on. And then we synchronize the radar depth data and the optical depth data and compensate for the clothing. Of course, there's a lot more complexity involved in reconstructing the body underneath, including the human models data set we use, the large 3D body scans that we've done in the past, we have learned from with people whom we scan, and the morphing algorithms we develop, and so on. But you get the idea from the high-level description here. We have a great team of researchers and developers working on the Cora hardware and software located in the United States and Vietnam. Now let's talk. When we started body data and focused on size matching, we knew that we had to solve the problem of scanning through ordinary street clothing in order to remove a barrier that was critical. The result is Cora. Now, extracting accurate body dimension data is necessary, but it's not sufficient in size matching. In size matching, you are dealing with an unlimited number of body shapes and a very small number of sizes of a particular ready-to-wear clothing style that have been designed for a particular body type. Remember, this is ready-to-wear clothing on the racks and not custom fitting, not custom clothing. You are basically putting square pegs into round holes, as we like to say. A size recommendation is the best size match possible between the two and not a custom fitting. You cannot get the body measurement and then use generic size chart to do the matching. You need to understand the clothing style technical specification, the sizes, the grading between the sizes, and so on. Then you must have a matching engine that understands how to match an almost, as I said, unlimited number of human body shape to the limited number of sizes for a particular style that's not likely designed for many of the body shape you're fitting. You need to have an understanding of the technical specification in the materials being used in manufacturing and its properties, like the elasticity property, and so on. Not to mention that in uniform, the job function for the end wearer needs to perform, like a flight attendant who has to put luggages up in the cubby hole, or has to reach down and pull out trays to serve the passenger. We take all these things into consideration for our size matching solution. Now, having the right measurement and the right size matching is still not sufficient. You will still have a lot of returns. To reduce return, you must also manage the end wearer's expectation that the size is not a custom fit and the clothing style was designed perhaps for a different body type than theirs. It's important to inform them how a particular size of a style will fit granular and critical parts of their body. If a style was originally designed using a fit model that is more rectangular, and you're trying to put a more curvy body shape into these sizes, it's not going to be optimal to some extent. They need to understand this size will fit them, but perhaps a lower size won't. As an example, if a woman gets a recommendation of pants size 6, and she puts it on and it fits her thigh and her hip perfectly, but it's a little loose on the waist area behind, she may naturally think, oh, maybe I should return it and get a lower size 4. And she'll return it, get the lower size 4, and it won't fit her because it won't go over her curvy body on the hip because it was designed originally for a square fit model. We know this and we can inform them ahead of time and manage their expectation, and thus reduce the returns and reduce their frustration. So that's how Cora is incorporated into our measure, match, manage solution for size matching. But Cora itself can be leveraged for opportunities well beyond apparel size matching. It can be used in healthcare. Today when you go to the doctor's visit, the nurse probably takes your height and your weight. But imagine if she scans you and gets all the body dimension. Now imagine in aggregate form all the body dimension of people over time and all the aggregated anonymous patient data. Using ML and AI, you can find correlation that are early detection for illnesses like diabetes. The body dimension of people can also provide a better understanding and mitigation of risk associated with life insurance. Same thing in health and wellness. Cora is a handheld mobile scanner capable of scanning through clothing and can be used from a security purposes in areas that it's too expensive or not possible to have a fixed big booth like at the airport with the TSA machine. Imagine courthouse, imagine sporting events that you need mobile devices that can be moved there easily, or multiple of them in a very inexpensive way. In summary, I hope I gave you a view into the innovation associated with our Cora scanner and how it removes the friction for scale in acquiring the human body dimension data, and how we leverage it in our measure, match, manage apparel size matching solution. Before taking any question you may have, I would like to conclude with a video showing our Cora scanner product. Thank you for your time.